right. It is November 29th, and we are at what? Episode number 2 for the year?
Yes, it's been a very productive year for the podcast.
I would say par for the course, really.
Turns out two guys with full-time jobs and families don't have a ton of spare time.
Here we are. You already know who we are. And by that, I mean you don't at all. For the 5 listeners that we might have for this podcast, yeah, I'm Aaron and
I'm Dell.
We're back at it again. Riding the ADHD hype train through all of the cool nerdery that we do on a semi-frequent basis, with a lot of starts and stops and maybe not as many finishes as there are starts.
Not nearly as many finishes as starts.
But man, sometimes it's about the love of the game, and yeah, so here we are. Dell, man, we're out here. Tell me a little bit what's going on with you, man.
I don't have a ton of new stuff going on. Still going to school. We've been hacking a COVID test. That's been kind of a good time. I don't really know why you'd want to fake a COVID test. I'm not really sure what the circumstances that the target audience for this thing is, but we've just been kind of doing it to see if we could do it, you know.
There are low-tech ways to accomplish this with pictures, I think.
Absolutely, 100%. This is just purely a exercise. I don't want to say in futility, but just like in doing nerdery. It's got an NRF52 on it, right? And they're really capable chips. And I've been thinking, it's like, man, if I could get this, maybe if we hack it well enough or whatever, if we get far enough, like we just repurpose this chip for something else. So, right, like there's a ton of this that I don't care about on the COVID test, obviously, especially because these tests are expired. So a guy at work just had them, and that's what we're trying to figure out is like how can you use an expired COVID test still? That's step one. But they have an app protect section on it. And they have an app, like authentication thing, right? They've got error checking on it, so it's got like a CRC 32 or 16 or something that we've been trying to overcome, and I think we've overcome that, but it's still got the app to protect stuff, so I got to figure that out still.
Yeah,
you're kind of along.
I think that with that too, you had made your first foray into glitching a little bit. Tell me a little bit more about that.
Yes, so let me double check. I should have opened this tab. So you remember when you got everything ready and I was like, I think I'm fine, and I was wrong. There is a guy on GitHub. His GitHub username is very creatively ATC1441, and he has a entire setup for using an ESP32, which I'm already kind of a fan of, to power glitch it. Now, I happen to have a scope, so I was able to tune things and figure out when stuff was going wrong, but basically, I was able to modify his code base and kind of his setup, his instrumentation from some cheap, like $50 Android watch to this COVID test, and I was able to power glitch it. And I've been able to power glitch 2 different ones so far, but I've got one that's still kind of eluded me, and I'm not 100% sure why. I don't know if that's just manufacturing differences or it's broken, right? I'm sure there's a certain amount of crib deaths that you have with those.
Yeah, no.
But I was able to power glitch it, and it was one of the kind of interesting things about it is that the COVID test takes so little power, you can actually power it from a single GPIO pin on a ESP32.
That's wild. What is that? And then what's the range there? Volt range?
So the volts is like 3.3 volts, which is what the COVID test takes too. So that was just kind of convenient. But yeah, the current draw is like it can source like 10 milliamps or something like that, and it turns out that's at least enough in order to run this COVID test for power glitching. If you try to run it on that when it kicks on the Bluetooth, it doesn't perform quite as well, and you need kind of external power. But for the glitching portion of it, it worked fine, and we were able to dump the firmware and dump a special portion of memory inside of the NRF32 called the UICR, which is the user something configuration register. And basically what that does is it holds all of the bits that are going to tell you, the bits and bytes, I guess, that are going to tell you things like, is app protect on? So I was able to dump both of those, and now I can modify both of them. And dumping user information configuration register, that's what that's called. The interesting thing about it is you can always wipe it. Even with app protect turned on, you can wipe it. But you can't dump it. So you have to power glitch it, dump it. You can make your modifications and then just wipe it with a standard SWD. I forgot to mention that because I just didn't take notes on this and did a bad job. But it uses an SWD connection, and I was not able to use my ST link that I use for my STM32s. I wound up having to go with a FTDI FT232H, which is kind of the classic bit banging various protocols.
One of my favorites. Near dear to my heart.
Absolutely.
A test bench
so once
must.
I got it, absolutely, I love the thing. And in this case, we have from some training that we did at work. I used it in the form of what's called an Addify badge. I don't know if you've ever used one of those, but yeah. So I wound up using that because I had it laying around. You know what I mean? And it was convenient for what I needed to do. And I've been able to connect it to OpenOCD, wipe it, reflash it as often as I needed, make modifications to the firmware as I needed. I've been kind of slow rolling it because me and the guy at work that we're doing a lot of it, we've both just kind of been busy lately with the holidays. And
yeah, no, hear that. Overcome by events. I think that that's something that the pod here has suffered from us both being, thousands of miles away from each other now. And as you'd mentioned at the start of the show here, busy with families and stuff like that too. But hey, man, every little bit that we get to be able to sync up again, we are. I know we definitely we recently threw down all of our notes and started a big section for a website between the two of us, and I think that it has the potential to grow into something that could have other people like guest users and stuff like that involved too.
Depending on the granularity of control of the shelves, you know what I mean?
No doubt about that. I think though that in general, getting a little bit more organized, I would say on the socials front too. Deleted X here a little while back and looking to move over to Blue Sky and or Mastodon. Already on an individual accounts for both. Trying to see, this is kind of the same as a Betamax VHS situation here. Which one is going to win out? Looks to me like the prevailing winds are going towards Blue Sky.
Right. Nobody wants to be the Hydrolox of social media.
So we'll probably end up getting the show over to those sections too. More to come on that, so we can get some updates through that. And if the website updates have any kind of like public forum that we would attach to it, I think it would probably end up going from there. But yeah, so in addition to the COVID test, RE, anything else you got going
on? I think that really is the biggest stuff I got going on right now. Is that thing I've been. So this is kind of weird and off topic, and I don't think I've talked about it much, but I've been working on slowly building a radio for my truck that's just Bluetooth and speakers.
Oh yeah,
Bluetooth and an amp with a screen to work on it.
Saw something similar from a good friend who unfortunately has some hearing loss due to some job related things, who is trying to figure out the ways that you can stream audio from a television directly to certain hearing aids. And it turns out, like most things, the hearing aids are proprietary, of course, and don't play well with a lot of the natural streaming capabilities that are built into a lot of the commodity IoT devices these days. But could be a potential future RE effort there, if only he's willing to give up some of his hearing aids. So we'll have to see how that goes. But I'm sure that there's a lower tech solution out there somewhere for having just those simple kind of radios. I don't know about you, but I just, there is something that really gets me going, like when with the absolute minimum viable product, like the bare essential bits, you can get something like that set up. I don't know what it is, but that really
I think that's honestly pretty totally understandable. I'm kind of in the same boat that I really love that those kind of like elegant minimalist, like effects driven, or I don't know, like very specific solutions for a problem. You have this device that it's no bloat, it's none of this BS. But on that same note, like I know some folks, we had a guy at a previous job of mine that had some hearing loss, and he just used, and it was work related as well, but he wound up just using AirPods, and they were, I guess, loud enough. I guess they've both got microphones in them, and they'll basically just act as like low grade hearing aids, I guess.
That is also a good segue into the microphone piece on those, the digital signal processing that is involved, I think, in basically anything that is listening to RF. You'd mentioned NRF 52 from the COVID test. Had the opportunity here to pop into a really cool little course. And the course was put on DSP related, and in it, There was a lot of good information that went out there, but it had linked up with a guy on there named Dan Boshin. And Dan was talking to me a little bit about some projects that he had been doing over at Microchip, where he's working. And by the way, this is not a plug. We have no sponsors. We're like a 5 episode podcast.
Yeah.
But anyway,
nobody wants us to plug their product.
yeah, but had worked on some direct memory access, inside of one of the Microchip microcontrollers that they have, to be able to remove a 1 kilohertz tone from like an audio file. So doing that mostly on the microcontroller through direct memory access. And I think they have a lot of good information that they're pushing out there, that he pushes out there, both in Python notebooks and some of the other things, which are good analogs really for what the hardware is doing at the low level. I'll share probably some of that in the show notes, but that's one thing that I have been messing around with quite a bit more, is the building your own bird feeder. I know you had mentioned a little bit earlier about the sometimes it's just it's not maybe the quickest way, but the best way is to try to figure it out for yourself, so that you can understand those first principles to be able to build something else on top of that understanding, which allows you to get to somewhere you wouldn't have got just by, I don't know, plug and chugging off of somebody else's type of project, I guess. But yeah, the DSP front. Yeah, the DSP information I'll make sure to share. And then there was a small time kind of private event CTF badge that we've been working on a bit. You want to talk about that just a little bit?
So the badge itself is mostly Wi-Fi Marauder firmware, which I think probably anybody that listens to this is going to have at least a reasonable concept of. So I don't know that I need to explain that, but it's compiled for a piece of hardware kind of colloquially known as the cheap yellow device, or CYD. And it's exactly what it sounds like. It's a El Cheapo setup. It's got a STM32WR00M32 on it. It's pretty standard module. What was that?
I was going to say, yeah, I think that for the Marauder firmware, just to actually explain that a little bit, because prior to us going into it, I didn't really know, but it's basically kind of like the Flipper Zero. It's kind of like
Flipper Zero.
Yeah, yep. It's kind of like the Flipper Zero, but on an ASP32. So it allows you the ability to do like Wi-Fi scanning and attacks, whether that be AP cloning or like deauthentication, or like an evil portal where it redirects them to over like some sort of like phishing type network that you have set up, or for Bluetooth to be able to discover different Bluetooth devices, or do packet injection, or I think there's some. Does it allow you to do AirTag stuff too, or Ponagachi detection? I'm not sure off the top of my head if it allows you to do that, but
I'm not sure off the top of my head either. Let me plug it in and see if mine is bricked right now. It is not. Oh, this I think is the brand newest version. So I'm not even sure that this is the version of the firmware from the CTF. It's not. This is the default firmware. So it's got Wi-Fi, Bluetooth, M device, which has like updating your stuff, and then in Wi-Fi we have sniffers, attacks in general. And then in Bluetooth, sorry, this is difficult to navigate. We've got sniffers and Bluetooth attacks. And I think some of the other versions of the firmware, you have kind of some of the more stuff. And the hardware supports all sorts of things, right? You have SD cards and interfaces like I2C and things like that you can use. And in fact, if you do it, or if you want, there's a way to actually install under ESP32 Marauder. You can install Marauder on the Wi-Fi expansion board for the Flipper Zero and kind of have both. And there's an app on the Flipper Zero you start up, and it'll send commands out to the Wi-Fi Marauder. But it'll do all the basic stuff like pretend to be an AirTag, or do all the BLE spam and things like that. Some of the attacks it has is Sour Apple, Swift Pair spam, Samsung BLE spam, Google BLE spam, and of course an application to spam them all at the same time.
That's super awesome.
And it'll do fun stuff on Wi-Fi, like you can do deauth attacks and stuff like that. So you sniff access points, and it'll save it to a file, and then you can select that file and you can do deauths on them. And well, all the fun that's associated with that if you want to piss your neighbors or a particular group of people in the local area off. So it's a really fun little board in general. So I don't know. I definitely recommend anybody check out the cheap yellow device in general, honestly. If you're looking for a cheap ESP32 project with a screen on it, they're like $15, which is pretty tough to beat, I feel like.
I think they're like $15 on Amazon and stuff like that. But if you were to really, be willing to go out there to like an AliExpress, I've seen them for as low as like $2.
Yep.
That said, I don't know how
And
much.
I think that's how the CTF got them.
Yeah, I don't know on the other side of that for import tax or any kind of other things that would be going on with that. What that real dollar amount shapes up to. I haven't bought any firsthand off the top. Really, we've just been playing around with the firmware that you had produced. But I will say though that this is the first time I have ever really had to contend with reverse engineering. Done some decent amount of ESP32 forward development because, man, just the ESP32, it's so capable. There's so much that it can do. At the same time, like doing the reverse engineering on the extensive side, like the assembly side for the ESP32, really first stab into that. It's more of that Harvard architecture versus von Neumann. It's just like anything, right? At the start of it, when you're at the foot of the mountain, you're like, okay, this is going to be a bit of a climb to understand all of the nuances when you're pulling something into Ghidra, or you're like, okay, I hope that they detect that, on the embedded side, when you're pulling something into Ghidra, okay, this isn't going to automatically find all of the different things that I would prefer for it to find. I'm going to have to do a little bit of like manual reading to be able to understand what the memory map layout might look like. And then I'm going to also have to understand, is there any kind of specific custom implementation information involved in this, which is different than what the kind of vanilla version of whatever the assembly language is for it. But I will say, despite that, it's been fairly easy going. And the reason for that, I think, is because probably part of the reason why ESP32 from Espressif is so popular too, they've got a lot of good documentation. And in addition to the good documentation they also have some really good build guides. And then on the other side of it, they've done something which I don't know if too many people have done or would do. They've created their own fork of QEMU to be able to like look at this off of the actual hardware itself. Now, we are stuck on some challenges with regards to emulating that hardware piece, but I will say that once we get past those, I think that it's going to be pretty easy to be able to like crack the nut on this a little bit. I'll pass that over to you to see what you might have to say off of that kind of long diatribe I had there.
So I definitely agree. I was absolutely not prepared for the Harvard architecture, and I still need to, I don't know, maybe find a tutorial or kind of get my head wrapped around how to do it in both Ghidra as well as GDB. You know what I mean? Where
Yeah.
you have the data address for everything and the instruction address for everything. So I got to kind of figure that out. It's I don't know. I think that's just a shortfall on my part. I just haven't done a whole lot with Harvard architectures. Everything I've done's been von Neumann. But at the same time, I absolutely agree. The documentation for the ESP32 is absolutely spectacular. It's easy to get a hold of. It's easy to search through and find what you're looking for. The other part is the tools that they have. I
Yeah.
was able to split the firmware image out easily with tools that come with the SDK
Oh yeah.
for the ESP32. And kind of what I mean by that, for anybody that's not familiar, is because the ESP32 supports things like over-the-air updates and things like that, the whole system is built around that. So when you build an application for the ESP32, you're actually running a small portion of the actual binary file, or the image that actually gets stored in your flash. And what happens is the bootloader kicks on, it starts to do its thing, and then it goes and it references a binary version of a partition table. And then that defines where your two applications are. So you usually have app 0 and app 1. App 0 tends to boot first, depending on the situation. Sometimes app 1 will boot if you have done an OTA or something like that. That's an over-the-air application update. So it's set up for that. And then if you don't use all of that memory, or you don't need all that memory, or you need storage space, you can put a SPIFs or a fat file system or something like that at the end of your flash for using in your application as well. And it'll define all that. And one of the tools it comes with is a tool to take a binary version of that and break it back out into the comma separated value version that you would normally build or normally reference in your in the SDK or in platform.io, if that's what you're using, whatever that happens to be. And it was just awesome to have a utility that went forward and backward delivered with the SDK and not have to go necessarily find some guy's random GitHub and hope that he implemented everything that you needed, or try to, carry on from their work.
Yeah,
Whatever
100%.
it happened to be. I love the tools that it comes with. I cannot believe they built their own QEMU, whatever. I'm not sure how to pronounce that. Build of it. I was like, holy crap! Like, they just deliver it with one, which is incredibly convenient. And now what I'm kind of thinking to myself is like, why doesn't everybody do that? Like, I would really prefer it if every chip manufacturer gave me an emulator that I could use for their particular cores. And realistically, with their entire chip, right? Because
Yeah.
like peripherals and stuff like that become a real pain on QEMU really fast.
No, you're right. I mean, the shtick with QEMU is okay. Number one, I absolutely love it, but there's a binary mode for QEMU. It's either your stuff works absolutely out of the box, first stab, you're good to go, or you're going to be spending a while trying to make that into the tool that you need in order to emulate the binary that you might have been pulling down if you just have the binary alone and you don't have any other types of hardware. From there, then, of course, too, you have to contend with the fact that there are a lot of different vendors who have bespoke solutions in the IoT space, and all of them have their different proprietary tool chains, yada yada yada. And my feeling though is that most of them do not co-opt into some of the tool chains which already exist, but instead create something just completely custom. So it's a breath of fresh air when folks like Espressif come along and they create a fork in this case of what already exists versus trying to create some absolutely just terrible, less capable thing, which would do far less. One thing I would say too, I don't know if you mess around with this, Dell, but I definitely did a little bit. I tried to play around with Renode a little bit. I know on the Ford development space that's been gaining some popularity. I haven't run into that on the Ford development side, but it is another seemingly pretty capable framework for allowing you to be able to emulate some of the hardware pieces, or just kind of knock out, if you will, some of the errors that you would get from binaries, which, okay, got it. Like, I'm not trying to exercise the functionality of the Wi-Fi chip or the Bluetooth, so I can, it's okay for me to like just kind of return all of those values as everything is okay. But I've heard and seen some pretty remarkable things on Renode. Are there any other types of tools that you pursued in tackling this guy too, outside of the ones that were provided by Espressif?
I don't think so. I think everything that I used was actually pretty much Espressif out of the box. They have the application for flashing, both reading and writing, the firmware and the chip and the various portions, and trying to get their build a QEMU working. But I think that's everything that I used on it,
Yeah,
unless you remember something I
no, there's nothing that's separate from that. I was just curious if you went down any rabbit holes outside of what we'd explicitly talked about or put down on the site. Could not say enough good things about Espressif. I think generally speaking, you hear kind of in the podcast space too from some of the other usual people in the embedded world. They've had some folks on from Espressif, and I think that their whole company philosophy and how it is that they go about approaching their projects seems to be at some point along the way that bottom up type of thinking, like thinking from first principles. And then aside from that, there's just some solid experience behind whoever it is who's developing a lot of these to be able to provide bits and pieces and tools and things like that to make your overall experience better. And I appreciate that. Now, that said, a quick pivot over to the Extensa side of the assembly. I will not say Extensa has been a pleasure to understand in terms of the actual instructions themselves. Thankfully, and I might throw this up in the show notes too. I probably will. I'll probably just export the page from that we were working on for the details of it. But when it comes down to all the different operations, a lot of the common ones that you see there seem very ARM-like. But the devil's in the details on some of those ones, which are more like this one instruction actually does 6 or 7 implicit operations under the hood that you don't see. That has been a challenge for me as I've been diving through this on the Ghidra front. So I've had to rely on that QEMU fork and GDB to be able to like help me through understanding where some of the hardware errors that I've been getting have been. And then not even aside from just the hardware errors, understanding what actually is happening underneath the hood on the calling conventions and the window register management and all of the stuff related to synchronization between the two, as well as interrupt handling. That has been not necessarily the most straightforward and fun process. Did you have a similar experience?
Yeah, the assembly on it has definitely been throwing me for a loop. I had to kind of give up, I guess, for a little bit for class, like we had talked about, but it was absolutely just kind of beating my face in. Honestly, I was not prepared for that at all.
Yeah.
Unfortunately, which seems kind of weird to me, but because I was like, oh, it's assembly. Yeah, I've worked with all this and I've worked with all that. Like, I think it'll be fine. But man, I was just absolutely wrong, and I can't remember what one of the instructions was. But I was like, holy crap! Like, what's going on with this, and why is it such a pain in the ass right now?
Yeah.
But
So
that being said, like, it is like overall going well, I guess. And I have also known and remembered that I absolutely suck at GDB, so that's something I need to spend some time getting good at.
it's like riding a bike. You get good at it for a month, and then you're like, "Oh, whew, I've gotten to the point where I don't have to use it anymore. I can use something else." And then some project not too long after that, you're like, "Okay, I got to start off with GDB again." And how do I do a hook stop? Oh man, how do I examine what size? Super thankful for them though.
Yes.
Super thankful for what they've got going on over there as well. So yeah, some more to come. I think hopefully on that we'll keep maybe charging away. I think we're gonna aim, and I am terrible. I think I'm probably like batting 0% here for claims that I've made on particular casts for things that will be going on in the future. But I think we've got to target dates on probably sometime here in December to be able to reattack that too if we can and see where we can get. But yeah, we'll see if we get there. But I'd like to turn it over to another topic that I think is really important when you are pulling off those binaries. We've mentioned it in some of the previous shows, but we haven't really got too much into which tools you particularly might want or why you might want them. And that's for how you can do file identification. This can come up in a lot of different ways. It can come up if obviously if you've got the system and you're taking a look at the binary that you have pulled off a flash, you probably have a pretty good idea of all of the pieces that are connected to that system and or the microcontroller or processor or whatever it is that you're taking a look at. But if you don't, and that's either coming up in a CTF or it's coming up, somebody just happens to pass something your way, there are a couple of different tools that are used that I'd like to talk to just briefly, and we'll share maybe some of our experiences here. First up on there's kind of 4 general categories been thinking about: malware analysis, file validation and preservation, general purpose and forensics, and specialized or niche analysis softwares. On the malware analysis, but not necessarily related only to malware analysis, we've got PEID, Yara, and Detected Easy or DIE. On the file validation and preservation, we've got Pronom, FDD, and TurID. On the general purpose forensics and just probably doing the most on most of the tools you've used, you got libmagic. I think ShareMem is in there too, but I haven't used that too much. I can't speak to it. And then on the niche analysis side, you got Magica and FDD. I'd like to start off by the most common libmagic, aka the file command and the stuff that's behind that. Definitely powers file, which is commonly used for this, and analyzing the headers and looking for signature structures that are associated with particular file magic. And it's standard on Linux and Unix, and super effective for general purpose file identification. You've used file extensively, Dell, or what are the ones from the ones I've listed maybe that you have used, and which ones have you worked well with, and or which ones have you maybe struggled with?
Honestly, I've usually just gone 1 of 2 routes. Well, 1 of maybe 3 routes. Of course, file is like usually where I start first. I just throw it in a Linux machine if I don't have it in one already, and I hit it with file and see what it comes out with. I think that's honestly the one. I'm just double checking FDD real quick. Like I've used that one, I believe. Yeah. with mixed success. But file is basically my go-to as far as like identifying what kind of file a thing is or something like that. Sometimes I'll just be lazy and I'll just bin lock it and see what it says. You know what I mean? Like just try to get it extracted if that's appropriate and everything in one go. But yeah, by and large, the file with libmagic, I don't think I've ever done a solo or a rolled my own implementation of something using libmagic. Is if file doesn't know what it is, usually I'm just going to have trouble with it anyway, and I go straight to the internet. There's that website. What is the I'm looking it up right now. Sorry, I should have grabbed this earlier. There's a website out there, and I can't remember what it is, but it's got a ton of like file signatures on it. This is the one I usually use, is GCK's file signatures table, which is exactly what it sounds like. It's just a bunch of magic numbers and a little bit of information about it. So those are honestly kind of the only route that I go. I don't know about which one of those you maybe used more often, but yeah, for me it's usually just file it, or I'm just using Wikipedia and Google to try to figure out what file signature that thing is.
Yeah, well, yeah, I definitely hear you on that. I would say that libmagic is definitely the workhorse for me when it comes down to identifying things which might be unknown. PID and tier ID are ones that I've used in the past for sure with regards to Windows executables. And really, usually when it comes to Windows executables that I don't understand, like ones which were created like by the Borland compiler or anything which wasn't just kind of typical VS Code or the full suite, anything that's like that, anything that has been created from the compiler that comes with Windows, I like to use those. And there are a couple of niche tools that we had talked about in previous episodes too for Borland and others that work out well. I haven't spent too much time in the malware RE space outside of academia, so I know that Yara is definitely something that a lot of people use pretty regularly to craft rules which allow you to make it a flexible, real Swiss Army knife for being able to do some heuristic analysis and not just like file magic. This really came up too, just to give some additional context to some of the folks who are listening right now. There is an absolute wizard of different file types out there. His name or her name is Angie Albertini, brought up also in a previous episode, but they had a recent presentation out there here back in October for an overview of the different file type identifiers. You may have seen, if you're in this space, Albertini is out at Google. They're a reverse engineer who has done malware, RE for the most part. Great website as well, Korkamai, that has some great posters too for different types of files and how they're deconstructed, has given some good presentations and or given some good information over to the Proof of Concept to Get the Fuck Out magazine, which is near and dear to my heart. I think Dell's as well.
Absolutely.
And wants to do what most of us want to do, right? You want to filter files quickly and reliably, but also accurately. I feel like there's probably an overlapping like series of Venn diagrams here that probably it's like that kind of typical pick two, but in this case, I think that the foothold you might want to get for something that's really just like not like got a clear MZ up front in the file is what you want to do. Oftentimes, I don't know, in the embedded world, what you'll run into is something that has been packed by maybe something like UPX or something along those lines. If you've let it boot and decompress and make its way into memory and then pull that memory off, if you had JTAG or something like that, you probably wouldn't contend with that. But if you just pulled it directly off of flash, there's a good chance you're going to have to contend with both the compression as well as what the file system or file type information for the files that it references are. And you might have to be dealing with flash, which is not present, or information at flash, which is not present inside of that binary image. So getting through and figuring out where each of those bits are is something that can be a real pain. But I know that I want to say that libmagic was what fed into Binwalk 2. For Binwalk 3, I think there have been some changes. There was at some point maybe a difference between developers or development out of the folks who used Binwalk, and there was an online system that I haven't, for nobody that I've talked to has used the online Binwalk. Have you used the online Binwalk?
I have not. I tend to prefer to avoid online utilities like that.
Right, right. So there's a low chance that I'm going to be uploading something to the internet for something that I'm really personally working on, unless it's just something I happen to download, and at which point I have the clear place where I'm going to upload it to, and that's Virus Total. But
Right.
from those sketchy places of the internet. But outside of that, I would say that yeah, Binwalk is the nice tool to use that's like built on top of libmagic. But outside of that, depending on what it is, if it's Windows, Detect Easy I like to use, or PRID. What else? What am I missing?
I don't know about anything off the top of my head. Honestly, you've kind of named all of the tools that I ever tried and more.
Yeah, I do. I will say that like one of the biggest challenges on the embedded space or IoT space, if you're looking at something that is uncommon, there could be any number of ways that somebody chose to be able to like marshal that data and or compress that data. So there's just always a good chance that you're going to have to be doing, despite any tools that exist, there's still a huge chance that you're going to have to do a lot of like manual work to figure out what it was, because some things are exportable, but most things are bespoke to that device. Do you differ from me on that perspective?
No, I definitely don't. Even if we just look at like the embedded space, I know a lot of folks I've talked to where they'll start with embedded stuff, and they get an image, hey, I pulled this off a flash chip, or I pulled this out of a memory on a microcontroller, or what have you, and they pull it into Ghidra, and they're immediately thrown by the fact that it's not an ELF format. You know what I mean?
Right.
And Ghidra doesn't know what to do. You've got to make your own memory maps and all of this other stuff, and that's all up to you. So I don't know, kind of in a situation there, pretty much where it's like anytime you have somebody that's come up with a bespoke solution, or even not necessarily a bespoke solution, but just something kind of out of the norm, they're, when you first start using Ghidra and stuff like that, a lot of people kick all that off with x86, and they just get thrown by a loop when they hit up some of that initial embedded stuff. As well as I have seen, I can't remember where, but I was working with a file format that was like a standard file format. It was, I don't remember what it was, but I was eventually able to kind of pin it down and figure out what was going on. But effectively, it was a known kind of common file format, but they just ripped the magic number off the front of it.
Right.
So utilities like Binwalk and libmagic and all of that stuff, they wouldn't figure it out. And I had to RE it for about 3 or 4 days before I was like, oh, okay, now I have enough, and then I could Google for what I had, and it turned out that it was a common file format. So, those are kind of the pitfalls I see as far as switching over to that less documented / more bespoke solution type of things.
Yeah, no, totally hear you on that. I think that there in that presentation, which I'll make sure to share too, there was a interesting empty file that Opportunity had created, which was he calls a polymock 191 yet empty file. And I know that in the past too, you've had some experience. We talked about this years ago, and I happen to remember it because it was funny to me. A coworker who didn't understand, like, they're like, oh well, everything that a file is identified by is just based off of the extension. So they thought that just if you named it, myfile.py, that's what created a Python file or not the actual binary contents which existed in it. So, but what I'm using that analogy or that story to draw a parallel to is if you have a lot of binary information that's in a file, it can identify as a lot of different things, and that's where Binwalk typically fails. Right? Like if you go super hard in the paint with Binwalk, and you can try to, if you go too hard with it, it'll take a really long time, and then it'll identify a lot of different things as multiple file types. It's super great when it can go up against something which is common, like a commonly compressed IoT file, and create the subfolders and pull out all of the file system and all that stuff. Like I'm thinking mainly there, like embedded Linux, right? If it's something that's not that, it's going to be like, oh, this is this crypto file, and you're like, no, no, it's not at all. That's actually just random binary data that comes from some maybe constants or something like that that's in it. So
I will absolutely say that one of the more comical and kind of frustrating things about Binwalk is I would say that it somehow manages to find something that it considers an AES S box in basically everything I run it against. Like, as far as Binwalk is concerned, there's an S box in everything.
That might have to be the episode title. An S box and everything.
It's so frustrating, right? Because you're looking through stuff and it's like, okay, and then like it'll find things that make sense. It's like, hey, I found a compressed kernel header, and I found this, and I found this, and then I found an AES box, and it's like, okay, well, is that a real thing? Does this have like libSSL in it or something like that, or is that a false positive? And then you get into it, and there's like no crypto in it whatsoever, or it's like triple des or something like that, and it's like you did not find an S box.
Yeah, no, totally hear you on that front. And but also this is why it's so fun, right? Because there's all these little things that you have to hunt down, and there's an infinite amount of side quests involved with it, and that's why we love it.
Absolutely.
But yeah, I think that's all I have to talk about in this episode. You got anything else kicking around in the old nugget?
Honestly, I really don't. Like I said, I just been kind of bearing down, getting to school and family and work and stuff at the moment. Some of which is coming to a conclusion here soon, so hopefully we'll be able to pick up episodes after that more often.
Hopefully not the family side.
But I think well, yeah. it's not. Spoiler alert, it's not family or job.
Cool. Well,
yeah, I guess I was needlessly vague about that.
I think it's good to leave it there for now. Yeah, I got nothing else myself as well. I think it's good to end it there, and with the vague promises, some more coming here in December. How do you feel about that?
That sounds good to me, man.
Cool. All right. So thanks for joining on to our biannual podcast here to listen to us ramble about a couple things here and there. Hopefully that might provide some footholds or handholds for you to jump onto for any type of projects that you're working with. And all right. Well, thank you all for listening. Have a good one.
repp.show. Nerd Talk IO.